Today I'm going to talk about recursion, and to illustrate this, I'm going to use an example. Let's say you want to buy a car. This car has a base price. This car has a base price here, right? Now, this car also has an annual interest rate, okay? So, the way to use interest rates here, like this 2.9%, is basically it's whatever, if you want to find what's the interest rate at the end of 1 year, you take the price, in this case 24,200, and you multiply it by 1 plus the interest rate. And the interest rate in decimal form, not in 2.9, but in 0.029. This will give you basically the price after the first year of this. And then you'll have to do the same, and then for the second year and so on, you basically will have to compute the price of that year. So I'll explain this a little bit more here. So if you want to pay the car up front, we're going to call that the base case, you have to pay 24,200. Okay? However, if you want to pay it, say in 3 years, right? If you want to pay it in 3 years, let's say you want a payment in year 3, well, that's going to be whatever you've paid, whatever your payment was in year 2 times 1 plus 0.029. So it's an interest of 2.9% over what you have already accrued on year 2. Now, we don't know the payment in year 2. So the payment in year 2 is going to be, it's the payment in year 1 times that interest. All right? So whatever you paid in the previous year times that interest. But then what's the payment in year 1? Well, the payment in year 1, it's going to be the payment up front, or the payment in year 0 if you want, times 1 plus 0.029. And what's the payment in year 0? The payment in year 0 is going to be 24,200, or our base case. Now, once we get to our base case, here's what we can do. We know that this is 24,200, and that's payment 0. So if we replace it over here, if we replace this number with 24,200, we can multiply by 1 plus 0.029 and get what we would pay on year 1. Once we know what we will pay in year 1, we can replace it back here, right? And multiply that by 1 plus 0.29 and find out what we'll pay in year 2. Once we know what we'll pay in year 2, we can replace it up here and multiply by 1 plus 0.029, and we will finally get our result. What we really want to know, how much we'll be paying in year 3. This is a recursive problem. This is a problem of recursion, where one answer, the final answer here, right, depends on the answer to the same question with slightly different parameters, a different year in this case. And that answer depends on the same problem, but with a different parameter, year 1 in this case, right? And so on and so forth. But the computation of the result is very similar. It's whatever payment you have times 1 plus 0.029. So this will be a clear recursive problem. So let's try to code it. I'm going to code it in Java just because that's what I have available. And this is a Java playlist. But you can code it in any language. So I'm going to create a little class called car payment just so I have a skeleton to wrap it in. And I'm going to create a little function which is going to be my payment. So I'm going to create a function, returns a double, and receives the year, just like this. This function, payment, will return a number that's a double, right? And receives the one parameter that I need is the year. That's the only thing I need, because the rest of the stuff I know. Now, what I'm going to say, if the year is 0, this is the base case, then I'm just going to say, well, what's the payment in year 0? well, just return 24,200. That's the payment in year 0. However, if it's not year 0, I will return the previous payment, the payment of the year minus 1, so the previous year there, times 1 plus 0.029, which is exactly what I did here. Now, this is my recursive function, and that actually works. So let's put it to work and see how it works. In order to do that, in Java, you might have to do something different in other languages, but in Java, what I will create is a main method. And in the main method, I'll create an instance of a car payment. I will also define a total, which is going to be the payment in year 3, right here, the payment in year 3. You see the cursor there, and I'm going to highlight it. It's the payment in year 3 right there, okay, which basically will trigger this recursive function, okay? And then, whoops, I missed that. Okay, so let me put it again. So I'm going to have a double total, which is going to be the payment on year 3, right? And then what I'm going to do after that is I'm going to print the price, the total price, right? So print total. All right. So with this, I'm going to compile this. You might compile this using whatever programming tool you use. I'm using a kind of an old school one, but if I run this with car payment, you'll see down here I get the result, $26,000, right? 26 something. So let me show you that again. Down here, 26367, right? So $26,367 at the end of the 3rd year. But what's important here is this. This is my recursive function. And the weird thing for many people is that the recursive function, say called payment, returns the same function with a different parameter, right? This can be done. This is an acceptable syntax in every language. So, and it's very equivalent to what we were doing here, where the payment on a given, the payment here, right, does have to do with, you still call the same mode of computing payments on a different parameter, in this case, a different year, right? It is the same thing. You're doing the same thing, but in programming. I hope this clarifies recursion, and we'll see you in a future video. Bye.